Right, what we're going to look at today is energy transformation and work. This will help you a lot with your discussion for your investigation. And the reason we're doing energy transformation and work is they're basically the same thing. Energy is the ability to do work, and that means that whenever energy is transformed or transferred, you're going to have work being done. However, the calculations for energy and for work are slightly different. So work, just like energy, has got the unit joules, so they're interchangeable. But this is where it gets a little bit tricky. These will be excellent type questions. We're going to go back to our old example that we used for potential energy of the diver on the 10-metre board. So we're going to, first of all, need to work out how much energy this diver has at the top of the board, or at the end of the board, so before he or she dives. So we're saying 55 kilograms of the mass. Gravity, we're told in our exam, is 10 newtons per kilogram, or they might say 10 metres per second. And we know that this person's going to fall 10 metres. So 55 times 10 times 10 again, is going to be 5,500 joules. Now, we're going to have to make an assumption to be able to do anything with this. Now, the assumption is not actually correct, but at level 1 and actually level 2 physics, we make this assumption anyway. We're going to assume that no energy is lost due to friction. Okay, now the force of friction would actually cause this person to lose some energy as heat before he or she hits the water. We're going to assume that isn't there. That's a key assumption that you have to put into your discussion to get excellence. Alright? So we're going to assume no energy lost. And I put it in inverted commas. It's not lost, it's actually transformed into heat, because you can't gain or lose energy. It can't be created or destroyed. It can only be transformed into something else or transferred something. Okay, so we're assuming that no energy is lost as heat due to friction. So that means that all of that energy is going to be turned into another type of energy just before the person hits the water. So they start here with no speed at all, but they're going to get faster and faster. And if you have speed or any type of motion, you have a thing called kinetic energy. And kinetic energy is given this equation. EK equals half mv squared. It's a really hard one to put into a triangle. So the way I normally put it into a triangle to make it easy to remember, this is more important probably for next year than this year, but we are going to use this today, is that I'm going to take the half out and I'm going to double the whole equation. So it's going to be 2ek is m times v squared. Now I can solve for mass, or I can solve for speed. In this question, I want to know how fast the person is going when he or she hits the water. Well, the first thing is that work will be done to transform all of that potential energy into kinetic energy. So the EK, or kinetic energy, is going to be 5,500 joules, because that's the same number as potential energy. Now, of course, it won't be that. It'll be a little bit less, because some of the energy will be lost due to friction, so we turn into heat. But we're going to assume that none of it is to make our calculation a little bit more simple and to work out what the maximum velocity or speed is going to be. We know the mass of the person is 55 kilograms. That doesn't change. Just by diving off a dive board, you don't suddenly become heavier or lighter, okay? Or, sorry, more massive or less massive would be the correct way to say it. So I can actually solve it. V squared equals 2ek over m. So I'm going to write that equation down. Now, of course, if we square root, we can have a positive or a negative value. We're just going to use the positive value because that's all we need to know. Right? So the square root of a number can be positive or negative. We're not going to worry about that. So to rearrange this, V equals the square root of 2ek over m. Now I'm putting brackets in there on purpose because that's how I'd put it in my calculator. The square root button, the bracket button, 2 times 5,500 divided by 55 bracket equals. So can someone put that in their calculator now, please, and give me a number? I don't want more than about 2 decimal places, though.
My hand's tired.
Square root of 200. I should know, don't mind. Sorry, off the top of my head.
Isn't it 1,000?
So about 14 metres per second, which is pretty fast. 14.1 metres per second. Okay. So we can find out the maximum speed that this person might hit the water. Now I've also said that it takes another 2 metres for the water to slow him or her down. So the water is actually doing work. So all of that kinetic energy is being turned into what? It can't just disappear. Well, it's turning into heat and sound. The splash from hitting the water and the actual heat from the water molecules slowing you down. So friction is now going to do some work. And for this I'm going to go over to the next board. And we're going to use our last equation that we use here, which is that work equals force times distance. Well, the work is being done by friction, so the water particles, that's my force of friction in the upward direction against the motion. The distance that it takes to stop the person is 2 metres. The work is the same as the amount of energy. So the amount of kinetic energy the person hit the water with, 5,500 joules, is the amount of work that the water has to do to slow the person down. So for this, we again can rearrange it. We know that work equals 5,500 joules. Starting to see this number repeat itself through this whole process. I know that my distance is 2 metres because it says so in the diagram. It takes 2 metres before this person can actually start swimming back up. Okay, so that means I can solve this for D. Sorry, not for D, for F, for friction. So the force of friction in this is going to be 5,500 divided by 2. So let's hope I don't make a silly mistake my maths here. 2,750 meters. That's covered 3 equations in one hit. And you can probably see why these are worth excellent. You're having to justify an assumption that you've had to make. You've had to rearrange a very hard equation. You've had to apply that to seeing that work is the same as the amount of the energy lost due to heat. And you'll see that this is very similar to a pendulum that you're doing, or you're swinging mass, because at its highest point here, you're going to have a change in height as it swings through to this point here. Okay. Here it'll be at its maximum speed. Now the speed's not important, but whatever its EP was here is going to be its kinetic energy here. Then it's going to push a block a certain distance. Well, that kinetic energy is also the work done by friction, so you can actually find out the force that this hits the block with, basically. And that might be really applicable to the wrecking ball example that you have to use. Okay, we'll stop there.